Alright, now the example that we are taking is suppose we are taking say 30 grams of MgSO4 is there. In this, how many atoms of oxygen are there? Alright, this is what your question was. Okay, first of all we'll get the RMM. Okay, so this RMM is 120. Okay, so if it is 120 grams of MgSO4, then how many atoms of oxygen will be there? No, I'm asking how many atoms of oxygen. No, it won't be, because in one molecule of MgSO4 there are 4 atoms of O. So it will be 4 multiplied by 6. Of course that 0.23 is there. In fact it is 0.22 into 10 raised to 23 atoms of oxygen. Correct? Why did I multiply this by 4? Because in one molecule of MgSO4 there are 4 atoms of O. Okay, so this is going to become this much. So just wait, don't make the calculation right now, because we have not asked for 120 grams, we are asked for 30 grams. So you take this as X and then simply cross multiply it. Okay, 120 grams of MgSO4 will have so many atoms of oxygen, so 30 grams will have how much? Okay, so this, if you calculate, is going to become 4 into 6 multiplied by 10 raised to 23 multiplied by 30 divided by 120. So this will be 1 jar, this will be 4 jar. Your answer is 6.022 multiplied by 10 raised to 23 atoms of oxygen. I'm having 4.8 grams of ozone. In this you are supposed to find out how many molecules are there of ozone and how many atoms of oxygen are there. Alright, what is the formula of ozone? O3. So what is its RMM? Okay, 48 is the RMM. Alright, so if it is 48 grams of O3, the number of molecules that will be present will be 6 multiplied by 10 raised to the power 23 molecules. So 4.8 will have how much? Okay, this is going to give me 6 multiplied by 10 raised to 22 molecules. Correct, because this is 10 grams, so it is going to become 1/10. I have to divide it by 10. Alright, so these many molecules of O3 are there. Now how many atoms of oxygen are there? See, one molecule of O3 is having 3 atoms of oxygen. Correct? No. No, that, yeah. These very molecules will have how much? Correct? So 6 into 10 raised to 22 molecules of ozone. This will have how much? Correct? Yeah. No, it will be multiplied. Okay? Correct? Because one molecule is having 3 atoms, so these very molecules of O3 will have how much? So it is going to be 3 multiplied by 6 multiplied by 10 raised to the power 23 atoms. 22, yeah, 22 atoms of oxygen. If you write this in the standard form, it is going to become 1.8 multiplied by 10 raised to the power 23 atoms of oxygen. Okay, I'll just give you a few examples. You just try to work them out on your. How many hydrogen atoms are present in 19.6 grams of sulfuric acid? Correct, RMM is 98. So the 19.98
98 grams of sulfuric acid, there will be 6 into 10 raised to H2
Okay.
into 2.
Correct. If I want the number of hydrogen atoms, then this number will get multiplied by 2. Correct. Because one molecule is having 2 hydrogen atoms. So this will be 2 into 6 into 10 raised to 23 H atoms. Now what?
So the 1.2 into 10 raised to 23.
Yeah, that's going to become 1.2 into 10 raised to 24.
Yeah, that's in 98 grams.
That is in 98 grams of H2SO4.
Yeah. So now in 19.6 grams will be 19.6 into 1.2 into 10 raised to 24 upon 98, which is 2.4 into 10 raised to 20.
Okay, that's clear. Yes. Now we'll take examples based on chemical reactions. Okay, the reaction balanced equation is given to you. Here 1.2 grams of MgSO4 is reacting with excess of H2SO4. We are supposed to find the mass of MgSO4 produced and the volume of hydrogen that is produced at RTP. Okay. Now first of all, what we are going to consider over here is the mole ratio. Here there are no numbers indicated, which means the number of moles of each of these substances is 1:1:1:1. Correct. Now here we are having 1.2 grams of Mg. So first what we are going to do is we are going to find the moles of magnesium. Correct. So moles of magnesium, that will be the mass of magnesium divided by its atomic mass. Okay, 1.2 divided by 24. Okay, this is going to become 0.05. Correct. So here the moles of each one of these is going to be 0.05, 0.05, 0.05, 0.05, 0.0. It will be same for all because here all the mole ratio is 1:1:1:1. Correct. If at some place the number 2 would have been there, then it would have become 0.05 multiplied by 2. We are going to take those equations also later. Okay. So here the mole ratio is this much. Now what is asked? The mass of MgSO4 produced. Whenever mass is there, we are supposed to know its RMM. Correct. Now we have done just the RMM of MgSO4. Okay, which is 120. So 1 mole, its mass is 120 grams. 0.05 moles is produced. Its mass will be how much? Correct. Simply it will get cross multiplied. So the mass of MgSO4, this will become 6 grams. Correct. 120 multiplied by 0.05. The next thing that is asked over here is volume of hydrogen produced. Correct. Now here also the number of moles of hydrogen that is produced is 0.05. So now we want here volume. So 1 mole is 24 dm cube. So 0.05 moles will be how much? Simply cross multiply this. Okay, that is 24 multiplied by 0.05. So the volume of H2 produced, this will be 1.2.
We have to multiply by 2 because we have 2 atoms.
No, we are not calculating here the number of atoms. We are calculating simply the volume. The volume of the 24 dm cube volume that is there, that is for H2 gas. If we are asked number of atoms, in that case, okay, It will be 6 multiplied by 10 raised to 23. That will be number of molecules for 1 mole. For these many moles, it will be 0.05 multiplied by 6 into 10 raised to 23. And if number of atoms is asked, that will get multiplied by 2.
1, 2, 1, 1, 1.
Correct? This is the mole ratio.
Yeah. So for CSO3 we'll have to do 7.3 divided by 2.
No. 7.3 is the mass of HCl. Correct? That's not the mass of CaCO3. Correct? So first what I'm going to do, here 7.3 grams of HCl is there. It means first I'm supposed to, whenever grams you see, you find the RMM. Okay? So HCl. The RMM is how much? 1 plus 35.5, which is 36.5. Okay, this is the RMM of HCl. Alright. Now, you see the mole ratio over here. Correct? Because this part is 2, then it is becoming half of that. Because here the ratio of HCl is to CaCO3 is 2 is to 1. This part is 2 and this part is 1. Okay, so whatever the amount of HCl we are using, the mole ratio of CaCO3 as well as CaCl2, this both is going to become half, because that is what is asked, mass of CaCO3 and mass of CaCl2. Okay, so now I'm going to find out the number of moles of HCl used. How many moles of HCl will be used? Moles of HCl, how am I going to get? The mass divided by its RMM. So that's 7.3 divided by 36.5. This is 0.2 moles. It means if this is 0.2 moles, this is going to become 0.1 mole. This is going to become 0.1 mole. This is going to become 0.1 mole. Correct? Because it should be half of HCl. Okay. Now, again here 0.1 mole of CaCO3. Find the RMM. Correct? And then you will multiply that by 0.1. Find the RMM of CaCl2. Okay, that will be multiplied by 0.1. Volume of CO2 produced, 24 dN cube is for 1 mole. So it will be multiplied by 0.1. That's going to become 2.4 dN cube. Simple. You can just work this out. Okay. Basically here we are supposed to get 0.1 moles of CaCO3. Okay, this is 40. This is 12. This is 100. So for 0.1 mole, it is going to become 10 grams. We want the mass of CaCl2. So this is 40. 2 multiplied by 35.5. That's 71. So this is going to become 111. Okay, so the mass of CaCl2 produced. Correct, it's 0.1 mole, so it is going to become 11.1. We have already calculated the volume of carbon dioxide, which was 0.1 mole, so it is going to become 2.4. Okay, I'm going to give you an equation now. You just try to work this out. Why? You don't need. Mole ratio is 1:1. Okay, that is fine. We are not given over here the grams or mass of HCl. We are given here moles. So no need to find RMM of HCl. Because directly here the number of moles only is given. So directly over here it's going to be, this is going to be 0.05, this is going to be 0.05, this will be 0.0. Correct?
And here it's 23 plus
of NaCl. Why we found out the mass of NaCl? Correct, because here we are supposed to find the mass of NaCl. That's why you found out the RMM of NaCl, which is 58.5. Okay, so how much will be the mass of NaCl produced?
That is in 1 mole. So you have to multiply that by 0.05.
Correct, this will be multiplied by 0.05. 2.925 grams of NaCl produced. How many moles of NaOH will be used up?
0.05.
Obviously, here the ratio is 1:1, so the moles of NaOH that is getting used up will be 0.0. Simple. Next question.
So the mole ratio will be 2:1.
Correct. Here the mole ratio is 2:1:2.
And the oxygen will be 32.
Correct. RMM of O2 is 32.
So in 4 grams, 32 grams is 1 mole. 4 grams will be 4 upon 32. So that's 0.125 moles.
Correct. So the mole is going to be 4 divided by 32.
Now you have to multiply that by 2.
Correct.
Moles of NO and NO2 will be 0.25.
Correct. This will be multiplied by 2. So this is going to become 0.25 moles. This is going to become 0.25 moles.
For the
mass of NO.
Will be 14. The RMM will be 14 to 16 to 30. That's 1. So now you'll have to multiply by that 2. So that's 60.
No.
60. There's 2 now. So
0.25 moles it is. Correct. We are supposed to consider this part, not the mole ratio which is there in the original reaction. We are supposed to consider the moles which are there in the data, that the sum that is given.
2 NO. So that'll be.
It's okay. No, that's fine. Because in the reaction, how many moles of NO is reacting? 0.25. So we should always consider that. Okay.
So that will be
30 multiplied by 0.25.
7.5.
Correct. The mass of NO used is going to be 7.5 grams. Then how much volume of NO2 is produced?
So at 1 mole will be 24 dm cube.
Correct. 1 mole is 24 dm cube.
0.25 moles multiplied by 24.
Right. So 0.25 moles. This is going to become of NO2 produced. Okay, now in the reaction 1.2 dm cube of O2 is produced. Find the number of moles of KNO3 used up and the mass of KNO2 formed.
The mole ratio is 2 to 1.
Correct. The mole ratio, first of all, 2:1.
Now we have to find the moles of each. So 24 is 1 mole.
Correct. 24 dm cube of O2 is 1 mole.
And it's 1.2.
So 1.2 dm cube is how many moles?
1.2 upon 24.
Right.
0.05.
Correct. So this is giving me 0.05 moles.
That we have to multiply by 2. So we get 0.1 for the other.
Correct.
0.1 moles of KNO3.
Correct. This is used, so this answer you have got 0.1 mole of KNO3 is used. Now how much is the mass of KNO2 formed?
KNO2 will be 34.
39. K is 39.
39 plus 40 plus 15 85. That's the 1 mole, and 0.1 mole will be into 0. So 8.5.
Correct.
Yeah.
So 85 grams is for 1 mole of KNO2. Here 0.1 mole of KNO2 is produced, so it is going to become. Next part is percentage purity. Alright. See, 10 grams of CaCO3 produced 2 dm cube of CO2 at RTP. We are supposed to find the percentage purity of CaCO3. First of all, the mole ratio. Two things are given in the data. Okay, CaCO3 and CO2. The mole ratio of both of these is 1:1. Correct? Here the mass of CaCO3 is given. Correct? So I am going to find over here the RMM of CaCO3. RMM of CaCO3. Okay, we have just worked it out. It's 100. Then the ratio over here is 1:1. So if I am taking here the RMM of CaCO3, that is, this is 100 grams. Then this is 1. Now here the volume of carbon dioxide is involved. So here 1 mole is there. So that is going to be how much? 24 dm3. So if this is 100 grams, that is supposed to give me how much? 24 dm cube of CO2. So if we are using 10 grams, how much of carbon dioxide should be produced here? 2.4 dm cube of CO2 should be produced. But in actual, how much we are getting? 2. It means there is some impurity because of which we are getting lesser amount of carbon dioxide. Correct? Now how are we going to get its percentage purity? Okay. So 100 grams of CaCO3 should give us 24 dm cube of CO2. So 10 grams must give me 2.4 dm cube of CO2. Okay. But in actual, here we are getting 2 dm cube of CO2. So the percentage purity, practical value divided by theoretical value multiplied by 100. Practical value means actually what you are getting. Theoretical value is the value that is calculated. Correct? So this is going to be 2 divided by 2.4 multiplied by 3.33. Okay. So percentage purity is 83.33%. The next example of percentage purity, we have to balance the equation first of all. Okay.
The RMM of MgCN2 will be 24 into 3 plus 14 into 100. So I think 100 grams of MgCN2 should produce 4 into 24, 48
Okay.
dm cube. So 50 grams should produce 24 dm cube.
This should give me 24 dm cube.
It's actually 18. So 18 upon 24 into 100. Percentage purity is 7%.
Okay, this will be 18 upon 24 into 100. Yes, we are going to solve this question. Okay, so basically here the reaction is between magnesium and sulfuric acid to produce MgSO4 plus H2. Okay, basically the reaction is
That is 1.2 grams into 24 upon 48. 1.2 into 24 upon 400.
Percentage loss mass. Okay. See, the equation that is given to us is CuSO4.5H2O. On heating, CuSO4, this is the solid residue that will remain. This will vaporize in the form of steam because of heat. Okay. Here we are supposed to find the percentage loss in mass. So we are going to find the RMM of this. We are going to find the RMM of this. Okay, or you can find the RMM of this because this is the loss. Correct? So we'll find this RMM. Out of that, this much will be lost. And then we'll find the percentage loss. Okay, so you can calculate this. Cu is 64. S is 32. Correct, I'll directly take the RMM of water as 18. Okay, this is 250. How much is this?
90.
So out of 250 grams, 90 grams will be lost. Okay, so the percentage loss in mass will be 90 divided by 250 multiplied by 100. This is the percentage loss in mass. Yes, see this question. 112 centimeter cube. Okay, the volume that is given is at STP, standard temperature and pressure. So here we are not going to take the RTP volume, which is 24 dm cube, but we are going to take the STP volume, which is 22.4 dm cube. Okay, 112 centimeter cube at STP of a gaseous fluoride of phosphorus has a mass of 0.63 grams. Calculate the relative molecular mass of fluoride. Okay, this is the first thing that we are supposed to. 112 centimeter cube. Its mass is 0.63 grams. If I take 22.4 dm cube, if I am supposed to convert dm cube into centimeter cube, I'll have to multiply that by 1000. So it is going to become 22,400 centimeter cube. This is going to be the molar volume. That's the volume of 1 mole, which is going to be the RMM. Correct? I'm simply going to cross multiply it to get the RMM. Okay? So its RMM directly will become 126. How I made this? Whatever the volume is, its mass is this much. So if I'm going to take the molar volume means volume of 1 mole of gas. Because here it is given at STP. I'm taking it as 22.4 dm cube, that is 22,400 centimeter cube. That will straight away give me the RMM. Let's see the second part. If the molecule of fluoride contains only 1 atom of phosphorus, then determine the formula of the phosphorus fluoride. Correct? Now here there is only 1 atom of phosphorus in this. Correct? So if I subtract here the atomic mass of phosphorus is 31. So this is going to give me. So this mass is going to be only because of fluorine. Fluorine, the atomic mass is 19. So number of fluorine atoms over here is going to be 95 upon 19, which is going to be 5 atoms of F. So the formula of its fluoride, there is 1 atom of phosphorus, there will be 5 atoms of F, so its formula is going to become CF. Okay.